Hello everyone, I am Manju. Today I am going to give the seminar of probability theory and stochastic process. Let us see the properties of autocorrelation functions. Consider that a random process of x of t is at least y since stationary, that is the autocorrelation function. Rxx of t1, t2 is a function of only the time difference tau equals to t2 minus t1. Then the following are the properties of the autocorrelation function of x type equation here. The mean square value of x of t is expectation of x square of t is equals to Rxx of 0. It is equals to the power of the process x of t. We know that for x of t, Rxx of tau is equals to expectation of x of t into x of t plus tau. If tau is equals to 0, then Rxx of 0 equals to expectation of x of t into x of t is equals to expectation of x square into t. Let us see the second property of the autocorrelation function. The autocorrelation function is maximum at the origin. That means mod Rxx of tau less than or equals to Rxx of 0. Proof. Consider two random variables x of t1 and x of t2 of x of t, defined at time values t1 and t2 respectively. Take a positive quantity x of t1 plus or minus x of t2 whole square greater than or equals to 0. Take the expected value. Expectation of x of t1 plus or minus x of t2 whole square greater than or equals to 0. Expanding the square. Expectation of x square of t1 plus x square of t2 plus or minus 2x of t1 x of t2 greater than or equals to 0. Let us see the third property of the autocorrelation function. Rxx of tau is an even function of tau. That means Rxx of minus tau is equals to Rxx of tau. Proof. We know that Rxx of tau is equals to expectation of x of t into x of t plus tau. Let tau equals to minus tau. Then Rxx of minus tau is equals to expectation of x of t into x of t minus tau. Also, let u equals to t minus tau. Rxx of minus tau is equals to expectation of x of u plus tau into x of u. Rxx of minus tau is equals to expectation of x of u into x of u plus tau, or Rxx of minus tau is equals to Rxx of tau. Let us see the fourth property of the autocorrelation function. If a random process x of t has a non-zero mean value, expectation of x of t is not equals to 0 and is ergodic with no periodic components, then limit mod t tends to infinity Rxx of tau is equals to x square. Proof. Consider a random process x of t with random variables x of t1 and x of t2, given the mean value is expectation of x of t is equals to x or not equals to 0. The autocorrelation function is Rxx of tau is equals to expectation of x of t into x of t plus tau, expectation of x of t1 into x of t2. Since the process has no periodic components, as mod tau tends to infinity, the random variables become independent. That is, limit t tends to infinity, Rxx of tau is equals to expectation of mod x of t1 into expectation of mod x of t2. Since x of t is ergodic, expectation of x of t1 is equals to expectation of x of t2 is equals to x. Limit mod t tends to infinity, Rxx of tau is equals to x square. Let us see the property of the autocorrelation function. If x of t is periodic, then its autocorrelation function is also periodic. Proof. Consider a random process x of t which is periodic with period t0. Then x of t is equals to x of t plus or minus t0, or x of t plus tau is equals to x of t plus tau plus or minus t0. Now we have Rxx of tau is equals to expectation of x of t into x of t plus tau. Then Rxx of tau plus or minus t0 is equals to expectation of x of t into x of t plus tau plus or minus t0. Given x of t is wide and stationary, Rxx of tau plus or minus t0 is equals to expectation of x of t into x of t plus tau. Rxx of tau plus or minus T0 is equals to Rxx of tau. Therefore, Rxx of tau is periodic. Sixth property of autocorrelation function. If x of t is ergodic, then has zero mean and no periodic component, then limit tau tends to infinity Rxx of tau equals to 0. Limit tau tends to infinity Rxx of tau equals to x square, where x is an mean value of x of t. If x equals to 0, then limit tau tends to infinity Rxx of tau is equals to 0. The seventh property of the autocorrelation function. The autocorrelation function of a random process Rxx of tau cannot have any arbitrary states. Proof. The autocorrelation function Rxx of tau is an even function of tau and has maximum value at the origin. Rxx of tau is also related to the power density spectrum through the Fourier transform. The form of the spectrum is not arbitrary. Hence, the autocorrelation function also cannot have the shape. Properties of cross-correlation function. Rxy of tau is equals to Ryx of minus tau is a symmetry property. Proof. The cross-correlation function for x of t and y of t is Rxy of tau is equals to expectation of x of t into y of t plus tau. Also, Ryx of tau is equals to expectation of y of t into x of t plus tau. Let tau equals to minus tau, then r by x of minus tau is equals to expectation of y of t into x of t minus tau. Put u equals to t minus tau, then r by x of minus t is equals to expectation of y of u plus tau into x of u is equals to expectation of x of u into u of u plus tau. R by x of minus tau is equals to r xy of tau. Let us see the second property of this cross-correlation function. If Rxx of tau and Ryy of tau are the autocorrelation function of x of t and y of t respectively, then the cross-correlation satisfies the inequality. Mod Rxy of tau less than or equals to root over Rxx of 0 into Ryy of 0. Proof. Consider two random processes x of t and y of t with autocorrelation function Rxx of tau and Ryy of tau. Also consider the inequality. Expectation of x of tau by root over Rxx of 0 plus or minus y of t plus tau by root over Ryy of 0 whole square greater than or equals to 0. Expectation of x square of t by Rxx of 0 plus y square of t plus tau by Ryy of 0 plus or minus 2x of t into y of t plus tau root over Rxx of 0 into Ryy of 0 greater than or equals to 0, or expectation of x square of t by Rxx of 0 plus expectation of y square of t plus tau by Ryy of 0 plus or minus 2 expectation of x of t into y of t plus tau by root over Rxx of 0 into Ryy of 0 greater than or equals to 0. We know that expectation of x square of t is equals to Rxx of 0. Expectation of y square of t plus tau is equals to Ryy of 0, and expectation of x of t into y of t plus tau is equals to Rxy of tau. Rxx of tau Rxx of 0 by Rxx of 0 plus Ryy of 0 by Ryy of 0 plus or minus 2 Rxy of tau by root over Rxx of 0 into Ryy of 0 greater than or equals to 0, or mod Rxy of tau less than or equals to root over Rxx of 0 into Ryy of 0. Hence, the above absolute value of the cross-correlation function is always less than or equals to geometric mean of the autocorrelation function of x of t and y of t at t equals to 0. Let us see the third property of the cross-correlation function. If x of t and y of t are two random processes with autocorrelation function Rxx of tau and Ryy of tau, then the cross-correlation function satisfies the inequality. Mod Rxy of tau less than or equals to 1 by 2 into Rxx of 0 plus Ryy of 0. Proof. We know that the geometric mean of Any two positive numbers cannot exceed their arithmetic mean, that is, if Rx of tau and Ryy of tau are the two positive quantities, then at tau equals to 0. Root over Rx of 0 into Ryy of 0 less than or equals to 1 by 2 into Rx of 0 plus Ryy of 0. Also we know that mod Rxy of tau less than or equals to root over Rx of 0 into Ryy of 0. Therefore we get mod Rxy of tau less than or equals to 1 by 2 into Rx of 0 plus Ryy of 0. Let us see the fourth property of the cross correlation function. If two random processes x of t and y of t are statistically independent and or at least wide sense stationary, then Rxy of tau is equals to x bar into y bar. Proof. Let two random processes x of t and y of t be jointly wide sense stationary. We know that Rxy of tau is equals to expectation of x of t into y of t plus tau. Since x of t and y of t are independent, Rxy of tau is equals to expectation of x of t into expectation of y of t plus tau. Rxy of tau is equals to x bar into y bar. Thank you.